So lesson 6-2 is add linear expressions. Now on your warm-up, you are practicing with the distributive property, and that's how we simplify expressions. Remember, when you simplify expressions, you need to make sure that you have no parentheses or no grouping symbols, and you have no like terms, okay? So, first thing I want you to do is write down this definition for linear expression. It says, an algebraic expression in which each term is a constant or the product of a constant and a variable raised to the first power. All right, so now we're going to, according to that definition, remember, it's a constant or the product of a constant and a variable raised to the first power. So, we want to sort these terms by writing the expressions in the appropriate bins. So we've got two bins. We've got a linear expression bin and a nonlinear expression bin. So you know if it's linear, it goes in the left. If it's not going in the left, then it's got to go in the right. Is everybody clear? All right. So what do you think about negative 5x squared? Where does that go? That is non-linear. And the reason it's non-linear is because the exponent is not to the power of 1. It's not raised to the power of 1. Is everybody clear? Yeah. How about this? Negative 4x plus 3. That is linear. Very good. How about 1/2 x minus 5? Linear. Very good. That's also linear. How about 6 over x? Okay, so I have some saying linear and some saying nonlinear. This one is nonlinear, okay? And I will explain to you why right now. All right, so the reason that 6 over x is nonlinear is because if I rewrite this, and you guys, again, you're not going to get this until maybe 7th or 8th grade, probably 7th grade. This x, if it's in the denominator of a fraction, the way it is rewritten is it gets brought up to the numerator, and then the exponent 1 becomes the opposite. So this becomes 6x to the negative 1. So because this is not raised to the power of 1, it's raised to the power of negative 1, this is a nonlinear expression. All right, and then what about x cubed plus 2? Nonlinear. And again, that's because the exponent is not to the first power. So now, example 1, we are going to add linear expressions. Now, when we add the linear expressions, you guys, we can do it with the circles and with the shapes, the circles, the squares, and the triangles. And then there's another method that I'm going to show you today, is where you are going to stack the expressions, okay? So, here we have, for example A, make sure you write this down, the quantity 5x minus 4 plus a negative 2x plus 2. The quantity negative 2x plus 2. Now, we're going to rewrite this expression. So here we have, what number do I have in front of each of those? Parentheses. Remember, if there's no number, it's not a 0. It's a 1. Very good. So here, if you're looking at this expression, we're actually distributing a positive 1 throughout the parentheses. Okay? So here we're going to take that positive 1, we're going to distribute it, and I'm going to show you what happens. Okay? We're going to distribute that parenthesis, that 1 throughout the parentheses. So 1 times 5x is 5x. 5x. 1 times negative 4 is negative 4. Over here we have a positive 1 times a negative 2x. That's a negative 2x. And then here we have a positive 1 times a positive 2. That's a positive 2. Now, look at each one of these terms. Here we have a 5x, 5x. Here we have a negative 4, negative 4. Here we have a negative 2x, negative 2x. And finally, we have a positive 2, positive 2. Does everybody see that nothing changed? So when we are adding linear expressions, when there is a 1 in front of the parentheses, we can just take the parentheses away. And then we just end up with that. And now we can combine our like terms. Okay, using our shapes, we're going to identify our like terms. So here we have a positive 5x and a negative 2x. And then we have a negative 4 and a positive 2. And so now we can combine our like terms. So 5x minus 2x is 3x. And then negative 4 plus 2 is negative 2. And there's your final answer. Now, when we're using the stacking method, okay, you guys write down this second method also, and then you'll be able to choose which method you want to use when you're doing your homework, okay? So here, when we stack, let me rewrite the problem. All right. So now when we're stacking it, we're just going to take this first one and put it one on top of the other, okay? We're just going to put it one on top of the other. So we're going to have, and again, we can just take away the parentheses, right? So we've got 5x minus 4 plus, when I take away the parentheses here, well, I'm going to put a parentheses on this one just because it's a plus negative. So it's going to be negative 2x, right? And then a positive 2. So when we're stacking, you guys, does everybody see like terms? Does everybody see this? Let me highlight it. These are like terms, and those are like terms. Does everybody see that? So we have our like terms in the same column. Got that? And then we can just add, like, for example, if we were adding, I don't know, 23 plus 14. You add the 1s, then you add the 10s. Here, we're going to add the constants, and then we're going to add the x terms. So, negative 4 plus 2 is negative 2. And then over here, we've got 5x plus a negative 2x is 3x. All right, so here we have a negative 3x plus 8 plus 6x minus 12. So again, we're just going to rewrite. And we can just take away the parentheses because we're distributing a positive 1. Okay? And yes, you guys, you do have to rewrite without the parentheses. Okay? So we have a negative 3x plus 8 plus 6x minus 12. Okay? If I'm doing the stacking method, I'm going to write negative 3x plus 8 plus, and then here this is going to be 6x. I don't need parentheses there because it's just a positive. And then minus 12. And then you'll see, again, see here, those are my x terms, and those are my constants. Okay? On the first example over here, okay, we're going to identify our like terms. So we've got a negative 3x and a positive 6x. And then our constants are a positive 8 and a negative 12. And now, on both of those, we can just combine our like terms. So, negative 3x plus 6x is 3x. Positive 8 minus 12 is negative 4. And then over here, same thing. 8 minus 12. If you need to see keep, change over here, you can. So this is going to be keep the first expression, the first number. Subtraction becomes addition, and then this becomes a negative 12. So there's your keep, change. So 8 plus a negative 12, of course, is negative 4. And then here we have a negative 3x plus 6x. That's a positive 3x. You get the same thing. All right. All right, so do this next one with your table partners. And on this one again, you can choose either way. I will do both. All right, so we end up with negative 3x minus 5 for both. So again, you just take away the parentheses for the shape ones. For the stacking, okay, you just make sure that you line up the like terms, they go in the same column. Very good. All right, so for example 2, now we're adding linear expressions now with rational numbers, okay? So, again, the process is still the same. You're going to, if you're using the shapes, you just take away the parentheses, okay? So here we're going to write 9 plus 1/3 x plus 2/3 x minus 8. Everyone with me? Now when we're stacking, remember, we have to have all of our like terms in the same column. So can I write 9 plus 1/3 and then 2/3 x minus 8 on this one? No, we got to put the like terms in the same column. So for this one, I have to use my commutative property to switch those around. Is everybody with me? Okay? All right. So we're going to write 1/3 x plus 9 plus, over here, we're going to write 2/3 x minus 9. And now we have our like terms all in the same, oops, sorry, yep, I see it. Yep, it's supposed to be minus 8. Thank you. Minus 8. Good catch. Very good. All right, so now we have all our like terms in the right place. Is everybody clear? Same columns. All right, now over here we can use our shapes. So we've got a positive 3x and a positive 2x. 2/3 x. 1/3 x plus 2/3 x. That's going to give me 3/3 x, which is equal to 1x. So we write just x. Very good. And then we've got a positive 9 and a negative 8, and that's going to be positive 1. So let's see, we get the same thing over here. 9 minus 8 is 1, and 3/3 x plus 2/3 x is 3/3 x.
1x.
Very good. So x. So this one was plus 1. And 1 times x is x. All right, so I did both ways. So here's the stacking method over here, and here's the shapes method over here. So on the shapes method, I just took away the parentheses, okay? And then you'll notice we need common denominators, right? When we combine identify our like terms, 6x and negative 5x, and then I said 3/5 and 1/3. I said, oh, I need common denominators. Common denominator with 5 and 3 is 15. So we get our common denominators, and then we rewrite our fraction. Did everybody get those fractions over here?
Yes.
Now look, this is how I showed my work on this side. So I got my common denominators like this. Does everybody see that? And then, once I do that, then I'm just going to ignore this, and then just look at this over here. Is everybody with me? All right. So when we combine our like terms, 6x minus 5x is 1x, which is x. Positive 9/15 minus 5/15 is a positive 4/15. Very good. Be careful. And then over here, we have the same thing. 9/15 minus 5/15, that's 4/15. That's a positive, right?
Yeah, positive.
And then 6x plus a negative 5x is a positive
Positive.
x. And we get the same thing. All right, so for this application, it says Alberto and Dylan get a weekly allowance plus C dollars for each household chore that they do. They plan to save 60% of their combined earnings in 1 week to purchase a video game. Their earnings in a certain week are represented in the table. If their parents pay $8 for each chore, how much money will they have to purchase a video game? So again, you guys, we're not writing all of this down. We're just writing the important information. And of course, the important information, one, of course, is how much they earn, right? So here, Alberto earns 10 plus 8C, and Dylan earns 15 plus 3C. Okay? It says they're going to combine their earnings, right?
Yeah.
What does combine mean?
Add.
We're going to add. Very good. Let's highlight some important information up here. It says they plan to save 60% of their combined earnings in 1 week to purchase a video game. So, combined means we're going to add. Right? So we're going to add those together. Okay? Also, they want to take 60% of their combined earnings. What does of in math mean? Right, of means multiply. So we're going to multiply 60% times their combined earnings. Is everybody with me? So let's write this down. 60% of combined earnings. Okay? Now, when we are multiplying or putting a percent into an equation, we have to change that percent to either a fraction or a decimal. Okay, I'm going to change it to a decimal. Okay, so 60%, that's per 100, right? So 60%, that's equal to 60 over 100. 60 over 100, if I read that correctly, 60 hundredths, right? So that's 0.60. And of course, do I need that trailing zero? Nope. So here, I'm going to multiply 0.6. That's the percent. Of means multiply, and combined earnings means we're going to add those earnings. Is everybody clear? So we've got 10 plus 8C plus 15 plus 3C. So here, you guys, when I wrote it in this expression here, I wrote it without the parentheses. I just took the parentheses away. So the next thing we're going to do is we're going to combine our like terms. So here we have a positive 8C, and we have a positive 3C. We also have a positive 10 and a positive 15. Okay? So, rewriting, we have 0.6, that's 60%, times, and I'm going to write this algebraically, which means that we're going to do it alphabetically, and constants go last, right? So, 8C plus 3C is 11C. And then 10 plus 15 is?
25.
So that's a positive 25, right? So now it says up here, I forgot to highlight that part, it says that their parents will pay $8 for each chore. So now we have to evaluate. Okay, so this part right here, this we need to evaluate. When C is equal to 8. So we're going to put 8 in for C. Rewrite the rest of the stuff. So 60% times 11 times 8 plus 25. So now we're going to use our order of operations, okay? So we have to do the stuff in the parentheses. So that gives me 11 times 8 is 88. So we have 0.6 times 88 plus 25. And now we're going to do 88 plus 25, which is 113. Very good. So 0.6 times 113. And yes, you are allowed to use your calculator. So let me pull that out. So we've got 113 times 0.6. And that gives us 67.8. So 67.8. How much money is that? How much money is that? $67.80. $67.80. You have to annex that 0. This is not 8 cents. This is 80 cents. Is everybody clear? All right, very good.